This is Glencoe Accelerated Math Lesson 9.5 on Slope-Intercept Form. So, when we talked about slope, we talked about slope being that relationship between x and y. We talked about slope being the steepness of a line represented by a number. We talked about slope being that same thing as our constant of proportionality, or the constant rate of change, or the unit rate when things were proportional. Alright? Slope-intercept form is the way in which we write an equation for a line that gives us the slope and the y-intercept. By doing that, it makes it really easy to graph. Okay? So, slope-intercept form we use the format y equals mx plus b, where m is our slope and b is our y-intercept. So if we had example 1, and we had the equation y equals 1/4 x minus 6. We have an x that we can represent, that we can replace with any value. We have a y that we can solve for, a 1/4 and a -6. Which of those would be my slope? Which of those would be my slope?
1/4 x.
The 1/4 or 1/4 x?
1/4.
1/4. What does 1/4 mean as a slope? Is my line increasing or decreasing? I'm sorry? It's increasing. It's positive. It's not going to be increasing a lot, but it's increasing. All right? Do we know anything else based on that slope of 1/4?
It's -6x.
Does the -6 or the, because if we KCA that, it would be -6, okay? Does the -6 have anything to do with the slope?
No.
No. Okay. So what is that -6 then?
The intercept?
The y-intercept. With this information, it's really easy to graph. Yeah. You ready? Yeah. Okay. What we're going to do, we're going to pull out a coordinate plane, and we are going to graph this equation on our coordinate plane. If your paper has enough space, please draw let's try for 10 each way. Okay. Yeah, be careful. Remember that when we are drawing our coordinate plane, you're going to, we number the lines, not spaces, and we keep it consistent. It's cut on top of the card. Okay. So if I had time to draw my coordinate plane, you should have time to draw yours, correct? Theoretically? Okay. I'm going to zoom in on our grid paper for the moment. Okay. My y-intercept is -6. So where do I put a point?
-6.
When x is 0, y is -6. Okay. Then one of the ways that we described our slope was the rise divided by the run, correct? So how far up divided by how far over? So if my slope is 1/4, how many times do I go up? So then I'm going to go up 1. And by over we mean to the right. How many places? 4. 1, 2, 3, 4. So I should have a point at 4, -5. Yes. Then we can make them both negative to add a third point. So if we go down 1, we would go to the left how many places? 4. 1, 2, 3. 1, 2, 3, 4. So we would have a point at -4, 7. Somebody stole my ruler.
Oh, is it this one?
I can use that one.
The whites do.
Shh, no names. And then I connect the points. Y equals,
Why don't we have 0 on the grid?
because 0 is that intersection between our two axes.
Oh.
Okay. So we have now graphed the equation y equals 1/4 x plus -6, or -6. Did that y-intercept help us out? Yeah. Because that automatically gave us a point, right? Okay. Is this an example of direct variation?
No.
No? Why not?
Because if x were to equal 0, then the y should also equal 0 for direct variation.
Good. So when x equals 0, the y also has to equal 0 for direct variation. Can we look at our equation and know that it's not direct variation? Yeah. Because if it was direct variation, would that -6 exist? Would we write plus 0? No. No, so if we have a y-intercept of anything other than 0, it's automatically not going to represent direct variation. Alright? Does that clear a couple things up with that?
Mm-hmm.
Yeah? Okay. Let's take a step back. Okay. Let's look at another example. Because guys, we're kind of combining examples 1 and 2 and example 3 and 4 into the same thing. Okay? Alright. An example 2, We're given an equation that's not written in slope-intercept form, but it asks us for the slope and the y-intercept. So what we're going to do is, so for that problem, we're going to manipulate our equation to get it into this format. Okay, would that be easier? Yeah. That would be easier than creating 3 ordered pairs or 3 or 4 ordered pairs for x and y for that equation and solving, right?
Mm-hmm.
Yeah. So then, let's do it. Example 2. In example 2, negative 4x plus y equals 2. Okay. We're trying to get this into the form y equals mx plus b. So we need to get the y on the left by itself, the x, y needs to stay on the left by itself, x needs to get to the right. So what are we going to do? Yes, sir?
Add 4x to both sides.
We can add 4x to each side. So then we have y equals 2 plus 4x. Do I like the way that that's written? No. What property is going to allow me to rewrite that the way that I want to? The commutative property. So how am I going to write this equation?
4x plus 2. Or y equals 2, 4x plus 2.
Y equals 4x plus 2. So then what is my slope? Excuse me? So then what is my slope? My slope is 4. What is my y-intercept? 2. Let's graph it. I'm going to graph in a different color on the same coordinate plane. If you want to redraw your a new coordinate plane, you're more than welcome to. Zooming in on my graph. Alright. What is my y-intercept? 2. So I need a point where? On the y-axis at 2. Okay. What is my slope? 4. Ooh, this one's not written as a fraction. So then what would be, if we have a whole number, what is my invisible denominator? 1. So that would say that I go up how many?
2.
I'm going to go up 4 and I go over how many? 1. So if I go up 4 and over 1, 1, 2, 3, 4 over 1, I have a point at 1, 6. When I create my 3 points, I like to go up 1, and then I like to do 1 in the negative direction as well. Could we go here and go up 4 over 1 again? Yeah. No, do what makes sense for the graph that you have. If you don't have space for one, do another one. That's okay. So, here I'm going to go down 4, 1, 2, 3, 4, left 1, and I end up at negative 1, 2. You know what? I'm going to go from the point 1, 6. I'm going to go up 4 and over 1 again just to make sure it stays in the same line. 1, 2, 3, 4 over 1. Are those in the same line? Yes? My ruler's not long enough, but that'll be okay. All right, and this is the equation y equals 4x plus 2 or negative 4x plus y equals 2. because we know how to manipulate an equation, does it matter how our equation looks when it's given to us? No, we can always manipulate it to get into y-intercept form. Okay. Most mathematicians, we like this form. Why? Because it's easy to graph. So if we were given, if we have to compare two things, if we have to compare two equations, it's a lot easier to have it in slope-intercept form and we can graph it. There are ways that we can solve besides graphing, and we'll get to those later. Okay? Questions? Give me a fist of 5 at your chest. How are we feeling? Fist, not great. 5, pretty good. Give me a fist of 5. Okay, so if I was going to do another example, do you want to do another example like number 1, where we have the equation and we just need to pull out the information? Like example 2, where we have to put the equation into slope-intercept form? Or 3, graphing? Do you want, show me, just raise a hand. 1, 2, or 3? Okay, so let's do another version of the example 2 with graphing. Alright, I'm going to erase. And we'll do another example like that. Okay. If you are following along in your book, let's look at example 2D. Oh, and that marker does not show up well. Let's choose another one. Alright, example 2D. X equals 2 plus y. X equals 2 plus y. Why do you think I chose this one in particular?
Because the y and the x is switched.
Because the x and the y are both on the wrong side. Good. So, let's look at what was the first. What's the first thing that we're going to do? Move what? So you want to move the 2. Does the 2 need to be moved?
No.
But if I do that, is it written in slope-intercept form?
No.
If we move the intercept, which is 2, to the side with our x, then we have everything on the same side, but we don't have, but it's not going to be written in slope-intercept form. Okay? So, what do we need to do instead? What do you think? We can either move the x or we can move the y.
Move the y.
You want to move the y first? I would agree. Let's move the y first. How do I move the y?
Pick it up.
You can't do that. You can't just pick it up and move it.
Oh.
How can we mathematically move the y? Yes.
Subtract x.
Add 2.
I guess subtract the y.
Subtract the y. So then we end up with x minus y equals 2. Okay? Then what?
Then you add x.
If I add x, then I would end up with 2x minus y equals 2 plus x.
Wait, what?
If we add x to both sides, we would end up with 2x minus y equals 2 plus x. Is that what I want? No. Nope, that's not going to work. So instead of adding x, what should we do?
Minus.
Subtract x. Negative y equals 2 minus x. Ooh, I don't like that.
Why not?
That's unfair.
Because my format needs to be y equals mx plus b, not negative y.
Y equals mx.
Well, then you add
Plus b.
negative to this.
Where'd you get mx?
Listen,
Yeah.
listen. The format of slope-intercept form is y equals mx plus b, where m is my slope and b is my y-intercept. Can I have this y be negative?
No.
No. How would I get rid of a negative?
Add it.
Add the y back.
Divide it.
No, you would add it times 2.
Stop. If I add y, then I would end up with 0 equals 2 minus x plus y. Not quite. If we would multiply by negative 1, would I eliminate the negative?
Yeah.
Would anything else change?
No.
So let's multiply by negative 1. That leaves us with y equals negative 2 plus x. Ooh, that makes our x value positive 2. Woohoo.
Oh. Ow.
Because when we multiply 2 minus x by negative 1, we have to take the opposite of 2 and the opposite of negative
Oh,
x.
you're right.
Okay?
You have to make sure it's even.
Exactly. Do I like the format y equals negative 2 plus x?
Yeah.
No.
No.
No. What property am I going to use?
We just need to add an m, right?
Nope.
You know, mx.
Hold on. What property am I going to use to reverse the order of my x variable with a slope of 1 and my y-intercept? The commutative property. So I can write that as x plus negative 2. What is my slope? So the slope is my coefficient, or that number that we put in front of our variable. If I don't have a number written there, what is my slope?
Nothing.
Not quite. 1. How many x's do I have? 1. So my slope is 1. What is my y-intercept?
Negative 2.
Negative 2. Okay. Questions about what we did. This was a little bit more difficult than the other one that we had.
Can we
There.
plot it?
What?
Can we plot it?
We're going to.
I don't have this.
What?
What?
Are there any questions about what we did in example 2D?
No.
Okay. Now let's look at our graph. We're going to go orange because it's really different. Okay, what is my y-intercept?
Negative 2.
Negative 2. So I plot a point on the y-axis at negative 2. Okay. What is my slope?
1.
1. So what does that mean? How many do I rise? How many do I run? How much do I go up? How much do I go over?
1.
I go up 1 over 1?
Yeah.
Yes.
Up 1 over 1? Can I do it again?
Yes.
Yes.
Up 1 over 1? Let's go down 1, left 1 just to make sure. And we will connect them. So, what questions do we have? What questions do we have? All right, thank you.
Gracias.